5 is over probability. We'll talk about the different types of probability when we use different formulas, what it means when we calculate probability. Probability on a scale of 0 to 1. 0 would be the probability of nothing happening, something not happening. 100 or 1 would be 100% chance of something happening. Most of the time you can't be at a 0 or a 1 unless you're just absolutely certain. I am 100% certain that a human being will walk through this hallway in the next 5 weeks. I'm pretty sure that's going to happen, but you never know, but I'm pretty sure 100% chance. When we talk about hypothesis testing, you're going to talk about the probability that something will happen, but we're not completely 100% sure because we can't 100% sure say that everybody in the population or in the sample will react in the same way. So if I come up with an experiment that found out that if you sleep 7 hours, you'll make 100 on your test, and then I have that one person who doesn't, we always have to accommodate for those outliers, the people who don't fit the mold. But for what we're talking about now, it's more perfect probability in that it's more predictable. We have where every observation is included in the possibilities. So like rolling a die, there's 6 different combinations that you can, or answers, solutions, experiments that you can have, or outcomes that you can have in an experiment. Outcome is a particular result. Experiment is the actual process of going through that. An event is the collection of one or more outcomes of an experiment. So my experiment would be rolling or flipping a coin 10 times. And I have the probability, of course, 50-50. So the more I do something, the closer to that perfect probability it should be. If I roll a die 100 times, I should have about equal chances of getting each number. There should be an equal amount. Mutually exclusive means that I can only be in one category or the other at the same time. So if I'm rolling a die or flipping a coin, I can't get a head and a tail or 2 heads in one flip. That's impossible. Mutually exclusive, I have to be either heads or tails. I just don't flip it and it lands on its side. Independent means that these observations or events are independent of each other. They don't affect each other. If I flip a coin once, I flip it again, nothing has changed the probability. But if I have a deck of cards, I say pull a heart, and you pull a heart and put it to the side, and now I say pull something else, what's the probability? Well, now I don't have 52 in the deck, I have 51. My probabilities are dependent on each other. Collectively exhaustive means at least one of the events must occur when an experiment is conducted. So something has to happen. Events are collectively exhaustive if at least one of these events must occur. I think it's just duplicated. We have 3 different types of probability that we'll talk about. Classical, which is just the equal likelihood of something happening. It's flipping that coin. Heads and tails, all equal probability. Empirical probability is the probability of something happening given a fraction of time events, something that's occurred in the past. And subjective means that I have other information that's going to impact my probability. So this is classical perfect probability. You have this in your homework problems. Total number of favorable outcomes divided by the total number of possible outcomes. So if I say what's the probability of rolling a 1, it would be 1 out of 6. There's 1, 1, and there are 6 different combinations of probabilities. If I say what's the probability of rolling an odd number, there are 3 odd numbers. There's 6 total. There would be 3 out of 6. Empirical probability is the probability of an event happening is the fraction of the time similar events have happened in the past. Law of large numbers means that the more times I do this, the more perfect the probability it should become. The longer I study something, for instance, the longer I go back, the more certain my probability can be. If all I do is look at, in this example for the space shuttles, if all I do is look at the last 5 years, then I show 100% of the flights should be flawless. And that's not true. You have to go back to make sure that you're gathering the correct information. So February 1st, 2003, which is tomorrow's anniversary, the Columbia exploded. There are 113 space missions that were okay. It's the second, or I'm sorry, that weren't okay. They were total. 111 were okay. 2 of those flights were not successful. So what's the probability, given this information, given this time period, that the number of successful flights, or that your flight would be successful launching a shuttle? It would be 98%. 111 divided by 113. Very straightforward, again, given the information that you have. For subjective concepts of probability, it's the likelihood of a particular event happening given the information that we have available. Examples, the Patriots make it to the Super Bowl, likelihood you'll be married before age 30, or that the budget deficit will be cut in half in the next 10 years. This is all given information that we have available. If we know the New England Patriots just aren't going to play football this year, we know that's given information. We know that the probability is impacted by that. If we know that the quarterback is hurt for a particular team, we know that's going to impact the probability of somebody winning. As compared to, in this one, if all my friends are married by 30, I'm 29, the likelihood should be more that I'd be married as compared to if none of my friends were married. So it depends on the information that I have available. And what we'll mainly be dealing with isn't this subjective probability because it's based on information. Just because you're not married by 30 but 100% of your friends are, that may mean something about you, not about the whole situation. But objective and probabilities, which are classical and empirical, those are based on more hard data information that we have. So that's what we're going to be dealing with. We have the special rules of addition. You have several problems, and the easiest way to keep track of it, remember that your problems are going to be asked. The exercises that you have are the formula they're looking for is probably the one right before it. So if you're reading the section in the book about the rules of addition, and then you have problems, this is the formula that they're wanting to use. So it can get confusing, but most likely it's going to be the preceding whatever we just talked about. So special rule of addition, if events A or two, if I can read, if two events A and B are mutually exclusive, that means I have to be an A or B, then the probability that one or the other events occurs is the sum of their probabilities. The key word here is or. What would change this probability if it was and? If I put and in here and I said they're mutually exclusive, is that possible? If this is, you're checking on a survey, male or female, they're mutually exclusive categories. Can you have male and female? Okay, forget all the freakish science stuff. Theoretically speaking, can you have male or female? Can you check both? If it's mutually exclusive, you can't. So this is the key here, that when you see this or, I know that these two things can't happen at the same time. That's the special rule of addition takes care of that. So the probability of these two events occurring are those added together. And we'll go through an example. This general rule of addition, if A and B are two events that are not mutually exclusive. So I have here that you went to Disneyland and you went to Busch Gardens and then you went to both. You can do both things. Then in this Venn diagram where they've intersected in the orange is that probability that somebody went to both. So what I'll do is take the probability that somebody would go to one of these would be the probability of the first one, plus the probability of the second one, plus subtract the probability of the two happening together. So think of this as like a deck of cards. What's the probability that you'll get a king of hearts? Where'd my mouse go? This would be the kings, this would be the hearts, and this would be the one that's going to be a king of hearts. Okay, example, we have a Shaw machine fills plastic bags with a mixture of beans, broccoli, and other vegetables. Most of the bags contain the correct weight, but there is some variation. A check of the 4,000 packages filled in the past month revealed this information. The probability that giving you this information in the problem. So what is the probability that a package would be either underweight or overweight? So it can't be both. It can't be overweight and underweight. So I take the probability of being underweight, the probability of being overweight, and that would be, adding those two together, it'd be a 10% chance that it would be overweight. What's another way of looking at this? Since there are only three categories, you can be overweight, underweight, or perfect. What would be another way of answering this question? What's the probability of a particular package being underweight or overweight? What's another way of asking that? Being satisfactory. Look at this. This is 10% and this is 9% or 90%. The two added together is 100%. You're going to have 100% probability. If you double check, everything should add up to be 100%. So if I look at this in the opposite, what's the probability of it being incorrect? Well, the opposite's what's the probability of being perfect or correct? The next one, probability that a card chosen at random from a stack of cards would either be a king or a heart. So I want it to be either one, which means I want to subtract out where it overlaps, because then that's duplicating it. So here I have the probability of A, and you can assign these however you want in the problem. They've already done this, but if it's easier for you to put probability of K, probability of H, do that. Whatever is easiest for you. They usually represent it A and B, but we can change that when we work out problems. So the first thing I want to do is figure out the probability of it being a king. That would be 4 out of 52. The probability of it being a heart would be 13 out of 52. And you're going to have a problem like this on the in-class test. You're not calculating anything really. This is just basic addition, subtraction. But you're going to have to think this logically through. The king of hearts, probability of it being A and B. There's only one king of hearts, 1 out of 52. So what I do is I add these two probabilities together, and then I subtract the one where they overlap. So I have the probability of it being a king plus the probability of being a heart, subtracting the probability of it being both. So I'd have a 30.7% chance of grabbing a king of hearts out of the stack, a king or a heart. The key there is or. Bless you. The complement rule is used, and this is what we just discussed about, okay, they want to know how many are defective, either underweight or overweight, or we can do it the opposite. We know how many there are that are okay, so we can figure out the other way. So the complement rule is used to determine the probability of an event occurring by subtracting the probability of the event that we're not looking for from 1. So I'm looking for event A, but I know all this event in the green, I just subtract out the circle. An example, if it will click. Same example here that I just gave you in class with the other problem. So here I have instead of figuring out what it's going to be for it to be underweight or overweight, I just figure out what it's going to be satisfactory and subtract that from 100%. If I am asked the question opposite, what's the probability of the bag being okay? Then I would take the probability of it not being okay, these two probabilities, and subtract them from 100%, and I would get 90. Or I can look on the table and find the answer. General rule of addition. There's a survey of 200 tourists who visited Florida at the same year, and they had 2 different places to go, Disney or Busch Gardens, or they could go to both. And they've given you the information. 120 went to Disney World, 100 went to Busch Gardens, and 60 visited both. And they've already put the probabilities in here. So what is the probability a selected person visits either Disney World or Busch Gardens? I cannot talk today. So I take the probability of Disney. Again, write this out. This is easier to do this. You don't have to stick with the A's and B's and try and keep stuff straight. The probability of Disney plus the probability of Busch Gardens minus the probability of going to both. So 0.6 plus 0.5 minus the 0.8. They have 0.3 up there. So I'm thinking it's just a typo. And then I would come up with my answer. It's the exact same thing. It's subtracting out where they overlap. Joint probability is that probability of something happening in both events that I'm talking about. So I can't have joint probability. This is the trick question that you may get on the test. True or false? I can have mutually exclusive events for joint probability. Would that be true or false? You can't have mutually exclusive events and have joint probability, because mutually exclusive means they don't touch, they don't overlap.